How's it going, everybody? Welcome to my channel. Today we have a very good problem for you guys called minimum swaps to group all ones together, right? She's the second one, right? So she's a sequel to the original one that we did, which was pretty good, right? It was a pretty good video. I got pretty good feedback. So I highly encourage that you guys go check it out so you guys can understand the overall process, right? So a swap, right, is defined as taking two distinct positions, right, in an array and swapping the values in them, right? So a circular array is defined as an array where we consider the first element, the last element to be adjacent, right? So pretty much what they're saying, right? What do you mean by circular, right? Is that this last element and the first element, right? They're pretty much neighbors, right? And they share like a border, pretty much, right? I guess you kind of think about, right? Okay, so they're part of the same subarray, right? So as this one, you could make a subarray with this one, right? So given a binary circular array now, right, return the minimum number of swaps required to group all the ones present in the array at any location, right? Okay, so this is a pretty simple problem, which I like a lot. I mean, pretty simple description. Okay, so what I'm gonna do here, right? So we have this nums thing, right? Right, our goal, right, is to pretty much group all the ones together, right? So what we need to do, right now there are three ones, right? We need to make sure that they all group together so that they're all sharing like the same border, right? They're like right next to each other essentially. Okay, so a swap that we could do is to change this one with this one, right? Then it would make them all of them together right there, right? One, right? As simple as that, like they have here. Okay, or we could bring this one here, right? And then all the ones will be here as well, right? Pretty much they all require one swaps, right? As you can see, there are other swaps that we could do, right? But would it be worth it? I'm thinking we could even do this one with this one, right? It would be fun as well, right? Or we could do, right? So it'd be one swap as well. So two swaps, right? We could bring this one right there, and then this one right there, right? And all the ones will be here. So it's two swaps. It wouldn't result in the minimum number of swaps, right? Which is not good at all. Okay. So well, what I'm thinking, what we need to do, right? This is a pretty simple example, right? So let's go big example, right? Which I think is more involved, right? So, which you can see this one is the similar one as the first one, right? But this one pretty much helps you see, right? The difference between this one and the other one, right? So the other one, right? Will result in this being one, right? Because we would need to swap this one with this one, right? So that all the ones can all be grouped together, right? But for this one, right, I told you guys the circular thing, right? This one pretty much right next to this one, right? So there are no swaps to be made because they're already together, right? Or grouped together, That's kind of the main difference, right? So those are neighbors pretty much, and we need to treat it as such, right? It's very, very important, okay? So how do we go ahead and solve this problem, guys, right? It's kind of, right? So we know that with this problem, right, we know the overall thought process, right? So our goal is to group all of them together, right? All right. So if there are X number of ones, right, we need to find a subarray of at least size X, right? Because those are the number of ones present, right? Size final one, there at least should be a window of size X, right? Where all the ones are right next to each other, right? All right, with that thought process, what we're going to do, right, what we did in the problem, right, we create a subarray, right, a window, a sliding window specifically, right, a static one that we make it of size X, right, which is the number of ones that are present in the array, right, because that's the target length that we're looking for, right, and we slide it across the array, right, trying to find, right, that, that window that will yield us, that would yield the pretty much the minimum number of swaps needed, right? So, and we do that slide of this amount, right? Because, right, if we know how many ones or how many zeros are present, right, we can know, right? For example, right, so we landed on that thought that as we're sliding, right, of lengths of this particular size, right, we know the number of zeros present, right, in the array, right? We know the number of zeros present in the array, right? That pretty much lets us know how many number of swaps that we need to do, right? Because the number of zeros present in that particular window, right, pretty much tells me that there are X amount of ones that are not currently present in that window. There are some other places in the array, right? It's kind of pretty much it tells me, right? Guaranteed that, right? So I know there's one at so I know there's three ones, right? And I slide, right? And this window I see there's 1 0 in there. It lets me know there's one outside of the window somewhere else, right? That's kind of the whole thing. That's how the other problem works. So it's quite pretty much a similar logic that we'll be using here, right? To help us know the minimum number of swaps that we need to make, right? Okay, but you can see for this example, it wouldn't work, right? It just doesn't make sense here, right? Okay. The answer is clearly zero, right? So your thing doesn't make sense here. Okay, okay, fair enough, right? So now, I'll say all this to say, right? So now we'll need to some sort of do like expand on our thoughts, right? And the way that we need to do this particular problem, right? Expand on it a little bit more. Okay. So, what I'm thinking here that we need to do, right? We need to handle the case where as we're sliding, right? Because we know that the window is pretty much like that, right? We have a left pointer, and right pointer, right? The right pointer allows us to expand, and the left pointer allows us to shrink, right, from the beginning, right? So we would expand with the right pointer and shrink with the left pointer, right? Uh, so to handle the case where we need to go instead of going out of bounds, right, and then boom, get index out of bounds, right, we need to somehow go to the front, right, and then keep continuing to the front, right, and have a termination, all right, you need to stop there and not continue doing it over and over, right, it wouldn't be too efficient, right, so we need to know how far we need to go in the front, right, as we're sliding, okay, so yeah, so how we would handle that, guys, right, pretty simple and intuitive in a way, right, okay. So now we have the right pointer right now instead of, so we reach, so let's also write the indices, right? Okay, index 0, index 1, index 2, index 3, index 4, right? Okay. So now once we get index 4, we need to go back to 0, right? So an easy way to do that, right? For this particular type of problem is by doing mod of the length, right? Modular length, right? So that pretty much keeps the index, right? Even though we keep incrementing it, right? It keeps the index that we're referring to, right? So let's say after index 4, right, what comes now is index 5, right? Okay, well, 5, right? 6, so on and so forth, right? All right. So those will be the other indexes, right? So increment the thing, right? And we want to keep incrementing it, right? So now we want index 5, right? You know, so right, we want index 5 and 6, right? Because we want to um for this particular example, right, we have 3 1s here, guys, right? Okay. So now I'm allowed to, right, uh to keep the sliding window intact, right? I'm allowed to do numbers of length, right, plus the number of ones that I have currently present, right? Because this is the amount that I'm allowed to expand, right, from the last element, right, and to continue picking some elements from the front, right. So I do a plus number of ones so I can extend my array by this amount, right? Okay. It's the key inside key understanding, right? And then, right, so I can expand it, right? So now this 5, right? We do 5 mod so 1, 2, 3, 4, 5, right? 5 mod 5 equals 0, right? So it references this index, right? And then we do 6, index 6, right? Mod 5 references index 1, right? So we keep doing it. It always stays, right? Even we were to keep like incrementing the index, right? By doing the mod, right? It makes it stay between that particular range, right? From 0 to the number of nums length, right? Okay. So that's kind of how we really simplify the problem here, right? And pretty much the same logic as the other one, right? But we just use this extra index, right? We expand it, right? And we use the modulo so that we don't get those index out of bound errors, right? Which can really mess us up, right? So that's kind of the overall logic. It's the only main difference than the original problem, right? So let's go ahead and quickly code that up. I think it'll make a lot more sense for you guys. And yeah, no, it makes sense. So what I'm gonna do, we know that we need to capture the number of ones present in our array, right? Because this is our target subarray, right? Length, so that all the ones can be grouped together, right? Okay. So we go through that array, right? A linear loop, keep it in simple. So I know how many ones I need, right? Okay. But now we do our edge case, right? Our check if the number of ones is less than or equal to 1, right? Then we know that I only need to do any swaps, right? If there are no ones, no swaps needed, or if there's only one, right? Then no swaps needed, right? We are good. Okay, so now that we've handled that simple case, what I'm gonna do next is to pretty much do initialize my left pointer, right? And also I capture my right, my min, right? So integer min that max value, right? Okay. And then what I'm gonna do is to also have a variable that helps me to track the number of zeros present in my window. And we start our linear loop, guys, right? So a linear loop will be simple, just like we did in the other one, right? Key difference. Okay. So we go all the way up to the end of the array, right? Right plus plus. But we did say that, right? We will allow the right to keep expanding, right? By number of ones, right? Number of ones minus one, right? Keep expanding, right? So we can keep, we can pick some element from the front, right? Boom, boom, right? So I can extend it up until that amount, right? And we know how we're gonna handle the case, right? Okay. So what I'm gonna do is to if, right? It's pretty much similar, right? So as I'm expanding, right? If the right pointer, um, the right pointer, right, is pointing at a zero, then I need to start tracking how many zeros I have, right, in my window. The increment my counter, right? And once I get to a size of one, right? Because that's the target length that I'm looking for, right? I want my window to be of nums of one length, right? Num one's length. Okay. All right. So once I have that, I can start capturing, right, the number of ones, right? So I see, all right. So I have a window of nums of ones, right? Because I'm citing it with that static field, right? A static size, right? I mean to say, right? We capture it. We see the number of ones. Then we do how many zeros are present in my window currently, right? And then I capture that, right? So if there is zero, then this will be the minimum amount, right? So the number of zeros lets me know how many swaps I need to do, right? Because the other ones are outside of my array that I need to swap with. Okay. So now what I'm gonna do is nums of left equals to zero, right? Before I increment the left pointer, right? Because that's one less zero that I need to account for in my window, right? It's kind of the overall logic. Okay. And after that, we are good to go. We just return min, right? Because that's what's capturing the minimum, right? So there's one thing that we need to do, right? Forgot to do. So there's one more important thing that we need to do, right? So we need to start, because since we're allowing it to keep expanding, right? Beyond the original point, right, which is nums of length, right? We're allowing it to, continue nums of ones extra, right? So what we need to do is to do the modular, right? And I told you guys we do that so that, as we right becomes 5, right, it needs to point to the first element index 0, right? So now we're going to mod it with the nums of length, right? So we keep stay within bounds, right? Here's the key insight here. Right? Actually, it's very, very common when we handle problems that are circular. That's kind of the key thing, right? Always should come to mind, right? I think it looks good to me. Let's press got a semicolon. Let's press this run code. Let me try again. It looks good. Third time's a charm. So pretty much a quick recap, right? We count the number of ones that are present, right? Because this is the window length that we're looking for in the array, right? And then we slide a sliding window, right, across the array, right? Of size nums of one, right? So that we can capture how many zeros are in there, which pretty much lets me know this is the number of swaps that I need to make, right? With the ones that are not currently present in my array in that current window, right? And then we allow the right pointer to keep expanding beyond the original nums of length, right? Beyond the original array size, right? We allow it to go nums of one extra steps, right? So that we can capture from the beginning as well, right? As it wraps around the array, right? It becomes circular, right? And yeah, it's kind of the main takeaway. First, we went to other problems. So yeah, Let's press submit, see if we better load test cases, guys, right? Okay, it looks like we did. Now, if you guys enjoyed the thought process, you guys understood the overall logic, let me know in the comment section. If you guys are new here, subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.